In this video, I want to talk about the general idea of Bayesian inference, which turns out to be extremely powerful. In a sense, some people think that all we ever do is do Bayesian inference. So let's talk, rather than talking about like parameters of Bernoulli models and stuff like that, let's talk about the world, right? And in the world that I'm thinking of, well, either unicorns exist or they don't exist. Another event that can happen in this world is my brain perceiving the fact that unicorns exist. Could be for any number of reasons. One reason could be, well, unicorns exist and one just walked in and I see it, or rather I see like a horse with a horn, which happens to be a unicorn. Maybe someone is pulling a prank on me. Maybe, maybe I'm hallucinating. Maybe it's that, quantum fluctuations turned out just so that the light that's hitting my retina forms the image of a horse with a horn, even though there is no horse with a horn. Could be any number of things. Anyway, let's put all of that into a probabilistic framework. So here's my prior belief that unicorns exist. I basically believe that there are no unicorns in this world. I would put it at like, 10 to the negative 10 is the probability of unicorns existing. So this is something that I just kind of came up with based on my experience of the world, okay? Which is of course kind of subjective. What is this? So this is the probability of me perceiving a unicorn given that unicorns exist, like ever. I'm a pretty curious guy. I would probably go to the zoo and see a unicorn there, right? So, so that's pretty high. Or kind of, I could just like stumble upon a unicorn. Now, here's the probability of me perceiving a unicorn given that unicorns do not exist. And where would I get this? Well, I just kind of like pulled it out of my hat, right? It didn't really, come up with it in any kind of rigorous way. But in principle, you could imagine me modeling like, all the physical phenomena which could cause my retina to have an image of a unicorn on it, despite the fact that there are no unicorns, right? And considering the fact that there is everything else in the universe. And I would model like the sociological processes that would lead to some people trying to prank me by kind of gluing a horn to a horse or something and sending the horse into somewhere where I'm as well, right? And I would model like, all the physiological processes that could cause me to hallucinate a unicorn despite the fact that there is no unicorn, right? And eventually I would come up with, well, a number that's kind of like that. Anyway, so those are things that I would either kind of come up with subjectively, or maybe I would try to model the world and I would try to come up with this stuff. So at this point, and this is really the power of Bayes' rule, which is really kind of a really simple equation, I could actually apply Bayes' rule and get the updated probability that unicorns exist, given that I've just observed that my brain perceived a unicorn. So let's just apply Bayes' rule. So what I'm interested in is the probability that unicorns exist, given that I think I saw a unicorn. So what is it going to be? So, the usual kind of Bayes' rule application. So the probability that I observe a unicorn, given that they exist, times the prior probability that unicorns exist, divided by P of I. So I'll just use the law of total probability straight away. And this is what it's going to be. So it's going to be actually the same term here, plus this kind of term, but for the event that unicorns do not exist. Okay, so that's going to be like that. So what is it? Well, so the likelihood that of observing a unicorn, given that they exist, that's pretty high. And now we'll multiply it by P of U. so that's going to be pretty small. This again. And here what we need is we need the probability that we observe a unicorn given that there aren't unicorns, right? So that would be 10 to the negative 4 times the probability that there aren't unicorns. So that's just going to be 1 minus 10 to the negative 10. So that's just going to be now we can kind of estimate. So it's pretty clear that this term is much, much larger than this term. So, so what we can do is we can just divide this guy by this guy, and that's going to be pretty much 10 to the negative 6, right? So that's going to be 0.9 times 10 to the negative 6. So we started out thinking that unicorns exist with probability 10 to the negative 10. Now that I've observed a unicorn, what I'll think is, well, that's the probability with which unicorns exist, which is, substantially higher, even though it's still pretty low. And unicorns, of course, do not actually exist.